Alright, this next tutorial is how you take your pulse pressures that you've found in your chart file and convert them into real pulse pressures. If you notice here that all your tonometer values with the little handheld probe are in volts. What you need to do is convert this volt, so in this case the spike, well, we'll look at one of these values. Clicking on the zoom feature. This is one particular waveform with a trough around negative 1.3 or 4 and a peak just above 0. And the mean for the whole thing will be the average area under this particular curve. The area under the curve divided by the time. That'll be your mean pressure for that particular waveform. So what we want to do is actually get the information for each of these specific waveforms into Excel so that we can determine, or at least calibrate this particular wave to known blood pressures that we took with a brachial arm cuff. So to do that, we'll run this particular macro, carotid 10%, and what it does is dump 20 beats worth of carotid values into the datapad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 20. So we'll copy those and bring them into Excel. So the useful information from this particular file, I'll just label everything properly for you. So this is time. This is the minimum tonometer value. This is the mean tonometer value. This is the maximum in the tonometer channel. The other things that we need to know are the brachial pressures. Brachial diastolic blood pressure, brachial mean arterial pressure, and brachial systolic blood pressure. This particular value you would have written down after you had done a regular brachial arm pressure, so it would probably be 80 or so. You need one of these values. Just make sure that this is in proper notation. And let's say our brachial systolic pressure was 113. We can calculate mean arterial pressure as the following: 1/3 of systolic. Actually put a multiplication sign there. Plus 2/3 times diastolic. If you don't know why this equation exists, go read up about it. We can take these and assume that for every one of those 20 beats, brachial blood pressure was very similar. So we'll just drag that down. Or copy them and paste them into all these cells. Now there are a couple assumptions that we make. One is that in the supine position, diastolic and mean arterial pressure in the brachial artery is similar in all other large arteries. So in other words, this particular value is equal to 80 and this particular value is equal to 91. But systolic blood pressure differs and becomes augmented when you, or gets larger as you move out into the periphery. So this particular value is not equal to this particular value. So what we need to do is to determine the relationship between these two and these two values and use extrapolation to determine what the systolic blood pressure in the tonometer should be. So what I'll put down here is a forecasted tonometer value, which is the same as the carotid or whatever, let's say carotid pressure, systolic. So, to determine this particular value, we use a function which basically determines the linear relationship between these two values and these two values. So you plot, essentially, this and this versus this and this. So if we type in forecast, and we put a little bracket, the value we want to use to extrapolate and determine systolic blood pressure from is this particular one. Now our known y's would be these two here, and our known x's are these two here. Using that specific equation, we now predict from this relationship what this pressure should be. And you get that relationship right there. If we drag this down, we will know all systolic pressures. So, from this particular parameter, you can then determine carotid pulse pressure. Using the simple formula of this particular value minus diastolic in the brachia, which you assumed was the same in all arteries. So you end up with a value for pulse pressure for every single beat. You can take the average of this if you like. For the sequence of beats, the average pulse pressure was 32 millimeters of mercury. So you'll use that in your calculation of arterial compliance and beta stiffness index. Those equations you should be familiar with and are in the O'Rourke paper, and that's that. So the next tutorial will probably be on what you do with your diameter analysis once you've got them out of the Brachial Tools diameter program.